everyone, welcome back, and we will be working on this unit. We are on day 4 of unit 10. We're talking about logarithms. Again, the opposite of what we were doing before break, exponents. All right, so if we wanted to evaluate log 7 of the cube root of 7, let's change that 7. Let's change this piece. So I have log of 7, and then I have 7 to the 1/3. And what you did in the last few days is how things can cancel out. So I have the 7 here and the 7 here, so those actually cancel out. So what I have left is 1/3. Ta-da! So try to change things from one form to another and see if things just work out for you. Okay, let's talk about the end behavior. So the end behavior can really help us out when we're looking at that +2. Remember, that's our k value, and that's also our asymptote, right? So it's graphing at the 2. Okay, so how does that affect our end behavior? Well, it affects our y. Okay, so as x is approaching infinity, f of x is approaching infinity. It's going up, right? Well, and as x is approaching negative infinity, what's happening to the y? Well, it's getting closer and closer to the 2 because that's our end behavior. That is our asymptote of 2. All right, when we're focused on these 3 properties, so we have product property, quotient property, and power property. So what we can do, let's think back. So product property, so if I had xm times x to the n, what does that mean? Well, that means I'm adding the m plus the n. The same idea happens when we're talking about logs. The product property is the same. We're just dealing with logs now. So if I have log of b, x and y, do you see that they're multiplied together? That means I have log bx plus log by. That means I'm adding them together. All right, quotient. Well, if multiplying means adding, then quotient must mean what? Let's think about it. So log b x over y, that means I'm gonna subtract. So log bx minus log by. Subtraction. Yes. Multiplying means adding. Dividing means subtraction. Yeah. All right. Power property. So the power. So if I have log bx to the a, what I'm going to do is I'm going to put that a in front. So I'm going to have a log b of x. All right, so I'm just changing what things look like. So I'm going to change from this form to this form. And then on day 5, I'm going to go the opposite. If it's adding, then I'm going to go back to multiplying. Okay, so day 4 and 5 go hand in hand together. So let's rock this out. So what does this mean? Log 2 14 times 11. Well, this means that I'm adding. So log 2 14 plus log 2 11. Again, it's asking us to expand. So we are expanding these logs, and then we will eventually solve them, okay? Or simplify. So log x minus log 100 because it's a division problem, okay? All right, moving right along. All right, let's rock out the next one. So we've got ln, so natural log w over y squared. Okay, so we have ln w minus ln y squared. We're not done yet because this is a y squared. So ln w minus 2 ln y. So you bring the 2 and you put it in front. All right, so I want you guys to try the next few, see if you can expand them, and check back. All right, so for number 4, I split them up because it's a division problem. That means subtraction. I brought the 17 in front. And if you notice, I have ln and then the e. So those actually cancel each other out. So my final answer is 2 ln x minus 17. Or natural log if you want to get fancy. All right, this one, I brought the -7 in front. And we also notice these two cancel out. So -7 log y plus 7. All right, for number 6, you're actually going to have 3 things because the 7 and the x squared are multiplied together. So you're actually going to split them up with the plus, and then the y on the bottom will be a minus. So again, try number 6 and check back. All right, so we have log 3 of 7 And then we have 2 log 3x. And then minus log 3y. Again, make sure you put that 2 in front because that was the exponent to x squared. All right, again, getting a little bit complicated. So make sure these are multiplied together, so these should be separate. So 3 log x plus log y minus 2 log z. Okay? All right, moving right along. So number 8, we can actually make even smaller when we find out that we have a base. When the base and the number, we can take something out, okay? So again, I have log 4 of 64 minus 2 log 4y, okay? So what can I do with this 64? Well, 64 is actually 4 cubed. So what happens, So what happens with this one, this is a y, okay? So what happens is these cancel out and I have a 3 left over, okay? Log 4 cancels out because these are the same, okay? So I have 3 left and then I have 2 log 4y. All right, so again, we're just simplifying as much as we can. When we have a radical, let's try out this one. All right, so I have log 7 square root xy. So what on earth does that mean? Okay, so let's say log 7, and instead of having this radical, we should put both of them to the 1/2. That would make things a little bit easier so then we can kind of see what is up, okay? Now we notice that these are subtraction problems, right? And then we have it timesing the 7. Okay, so it's 7 times this whole thing. So that means I have log 3 of 7 plus log 3 of x to the 1/2. And then I have a minus, because this is a division, minus log 3 of y to the 1/2. All right. Do we need to simplify more? Yes, because this exponent I need to put in the front of both. So then that would be the last step, okay? So these can be pretty easy if we just break it apart. Little mistakes can definitely happen with these, like, oops, I forgot to add or I forgot to subtract for those. Alrighty, okay, so let's move right along to the next 3. All right, so I want you guys to try these. So if it's x to the 1/3, or if it's the cube root of x, I would change that to an exponent, so it's a little bit easier to deal with. So xy to the 1/3 over w squared. So how would you break this apart? These are both to the 1/3. What do you do when you multiply? And then what happens when you divide? How do you expand this problem? And then for number 11, again, I have log 8 64 over the square root of x plus 1. So this whole thing I would change to the 1/2, break it apart, and simplify. So try out 10 and 11 and see what happens. All right, so that should be your answer for number 10. All right, number 11. So if we break this apart, so we have log 8 of 64 minus 1/2 of log 8 to the x plus 1. Okay? Because again, the square root of x plus 1 means this whole thing is to the 1/2. So I can move that 1/2 to the front. Okay? If these were broken apart like this one for number 10, if it was multiplying, then you would break it apart and they would be 2 separate sets. Okay? But in this situation, x plus 1, that is one factor under the radical. All right, so log 8 of 64, log 8, well, 64 is 8 squared. So actually, this can cancel out, and I just have a 2 left over. And then I have 2 minus 1/2 log of 8, and then x plus 1. Again, this is one factor, so I can't break it apart. All right, moving on to number 12. Okay, so what does this mean? So I have log of 1,000 x to the 1/4. Again, this is multiplied together, so I can actually break these apart and give them both a 1/2. That is not the case when it's x plus 1. I could not just break it apart and give it to both. That is not the case for if it's a plus or a minus. That's 1 unit. This, break it apart. Log of 1,000 to the 1/4, okay, plus log of x to the 1/4. And what do? I bring it to the front. But there's some things that I can kind of actually work out for this one. So let's kind of see what I can do. So I have 1/4 in front, and then again, let's see if I can make this a bit smaller. All right, folks. So I have log of 1,000. Now, if I don't have any base right here, we need to know that that's actually a 10. And 1,000 can actually change to 10 to the 3rd. So we've got 1/4, and so log of 10 to the 10/3. I'm kind of writing a lot more down than I need to just to make sure that we understand this. So what happens, this cancels out, and I have 1/4 times 3, okay, which is 3 to the 4th. And then I can bring this down, plus 1/4 log x. So make sure that you can look at this number and see, can I cancel out the log, okay, based on what that base is. All right. Okay, so, and then for number 13, break it apart again. I have ln 7 plus 3 ln y minus ln 4 minus 2 ln x. So again, if these are multiplied, these are separate. This is separate also, okay? So that's why it's so long-winded. All right, try out number 14. Break it apart. Okay, look at each thing as its separate unit and see what would be your final answer. And your answer is A. Dun, 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 dun. Woo, woo. All right, guys. So I hope you enjoyed this magical lesson, and we will see you in class. Peace.